All right, so here's your homework assignment one more time. If you still need it, please get a copy down. We have 5 problems, 2 from the first section. We don't have anything from the second section, 24 through 26. Please take a look at those now that you have your books. Is there anything in that section that you would like to see done?
25.
Huh? Yeah. 25? Okay, then 5 or 9, which one do you want me to get rid of? Are you okay if I do 9 instead and turn this into a 25? And that way we'll have 1 from each section and we'll have 2 from the last one. Okay? And then if we have time, I'll cycle back through if there's something else that you missed. So up first is number 9. What does number 9 say, please? Doesn't this just say find the distance and midpoint of between the 2 points, right? Okay, so what are the 2 points for number 9? 8 and -4? Okay. So which one do you want me to find first, distance or midpoint? Distance. All right, so the distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So all you do is plug in, what's my x2 value? Okay. 8 minus, what's my x1 value? -4, that's quantity squared, plus y2 is -4 and y1 is 8. Everybody okay with the substitution step, yes or no? All right, so now for the evaluation step. Yeah, if you're typing it into the calculator with one move, you want to open with a parenthesis here and then close with one there. All right, so what happens to the double negative inside? It becomes a what? Positive. What's 8 plus 12? 8 plus 4? When you type it into the calculator, you have to explain to the calculator that the square root runs the entire length. No, you have to put this set in parentheses because of the square. Okay, so what's going on is the calculator reads this parentheses where the square root starts. So if you put this one here as a stop, it's only going to have the radical cover this first section, just the x's. Okay, but the whole thing has to be included, so you need a double, because this set here, here, and here is for the radical, and then these 2 are for the x section, and these 2 are for the y section. Yeah, like to be honest with you, I'll show you how I do these in a minute. Okay, and you can use the calculator, or depending on where your mental math is at, there's a lot of shortcut you can take. Yes. All right, so what's 8 plus 4 here? Squared. 144 plus, what's -4 minus 8? Squared. Okay, 144 plus 144 is 288, right? But remember, we have to reduce these. So real quick, how many 144s do I have here? 2, right? And what's the square root of 144? 12. So this is 12 square roots of 2. Do you all remember how to reduce down a radical, or do you want me to run through it again? Okay. So, we have the square root of 288. In order to reduce this, I have to find 2 numbers that multiply together to get 288, but I want one of them to be a perfect square. So what's the biggest perfect square that can go evenly into 288? Not 12. 12 isn't the perfect square, but 144, right? Remember, your perfect squares are 1, 4, 9, 16, 25, 36, 49, right? Those are the perfect squares, not the number that we squared to get that number. So I see right here that I have 2 144s. So 288 divided by 144 is going to be what? 2, right? So I get 2 times 144. Well, we have the nifty property in math that the square root of a product is the product of square roots. So what that means is I can split this apart and get the square root of 144 times the square root of 2. Well, what is the square root of 144? 12. So I get 12 square roots of 2. Okay? So remember, whenever you see a radical, to reduce it, you want to find the biggest perfect square that goes evenly into it. Okay? So do you want me to run back through the list of perfect squares? Right? Because you all should know up to 15. So you need to have those written down. I told you to write them down last year. This is where we're still using that idea. So whenever you see a square root, it has to be reduced. Okay? Some of you might be able to cheat with your calculators if your calculator has math print mode. under your mode settings, but most of them don't. Okay, I do not want a decimal for these. I want a precise answer, so I'd like to see 12 square root of 2. Everybody all right? Now, you can use your calculator to check yourself, right? Like, on your calculator, if you put in 12 square root 2 and hit enter, you get a decimal, right? Well, if you put in square root 288 and hit enter, you should get the exact same decimal, okay? So if you want to check to see if you're reducing properly, you can use the decimal approximation out of your calculator to guarantee accuracy. Everybody good with that? Yeah? So that's going to be the hard part in this section, is reducing down your radicals, okay? So if you get to, like, square root of 288 and you don't remember how to reduce it down, right, on Monday, make sure that you come and see me and we'll run back through it. Everybody all right with that? Yeah? So do not write decimal approximations here. I want exact answers. Everybody good? All right, so that's for distance, right? Anybody still need distance? Okay, so what else did they ask me to find? The midpoint. So midpoint is super quick and easy, so give me 1 second here to clean up. All right, midpoint. What letter do I use for midpoint? Big M. And the formula says x1 plus x2 over 2, comma, y1 plus y2 over 2. So remember, this is a point, right? So it needs to come out as an ordered pair with a comma in the middle. So basically, I'm averaging my x's and I'm averaging y y's. So what is x1 plus x2? So what's negative 4 plus 8? 4 divided by 2. Okay, y1 plus y2 divided by 2. There's your midpoint. Okay. Everybody all right? Yes, no, maybe? Okay, now I want to come back to distance real quick so I can show you all and RJ in particular what I was talking about. Well, you're going to lose like a half a point. Like on the homework, it'll be marked wrong, right? On a quiz or test, you'll lose like a half or a quarter. But if that's where you can get to over the weekend, then when you come in on Monday, I'll go back over it with you in particular, or with like whoever's got that issue, and I'll give you an extension to get it fixed. Okay? But I just don't want you copping out and writing down a decimal. Leave it in radical form, and we'll go back over how to reduce out of radical. So, like, when I do distance, I never use the formula. I mean, I use the formula, but I don't write it in like that. Okay, I know I'm going to subtract my x's and square, right? Negative 4 minus 8 is negative 12. Squared, that's 144. Plus 8 minus a negative 4, that's a double negative. 8 plus 4 is 12. Squared is 144. This is the first line you will ever see on my homework. Okay, I jump from the point to here. Feel free to do that. Just be accurate. Yeah, okay? Yeah, as long as you can not screw it up, you can skip around on these. Yeah, and with you all, your mental math is pretty solid, so go ahead and do it. Just be careful of the double negative. That's the only thing that's going to throw you off on that. Okay? So for me, the big M, you would see one line, you would see this, right? Big M equals 2, 2. And the distance would be this, and then square root of 288 equals 12 square roots of 2. So it'd be 3 lines for both answers. Everybody okay with that? Yeah? So again, you can skip around on these as long as you're right. Yes. Yep. Just leave it under the radical if it cannot be reduced. So like if it were like 21, right? The only things that are factors of 21 are 1, 3, 7, 21. Are any of those perfect squares? All right, so there's number 9. I know that took a while. My apologies. Up next is number 25. What does number 25 say, please and thank you? Positive 6? Okay. So what do the directions say here? They want you to determine what? What do the directions say? They want you to determine the type of triangle this would form, right? If I plotted these 3 points, what kind of a triangle would I make? So what are the 3 types of triangles based off of side lengths? We went through them yesterday. Isosceles, scalene, and equilateral, right? What does isosceles mean? 2 sides are the same. What's scalene? No sides, and what's equilateral? all sides. So again, what I'm going to do is I'm going to find the distance between point 1 and point 2, the distance between point 2 and point 3, and the distance between point 3 and point 1. And then I'm going to look and see what's the same. Yeah, like AB, BC, CA. Yep. Yes. Now, the nice thing here is you don't really need to reduce down radicals and all that stuff. Okay, a square root of 288 and a square root of 288, they're the same. That's what I'm looking for. Are we going to be getting the same values for the lengths? Okay, which of our side lengths are the same? That's all I'm trying to find. So, again, this is where if you can take shortcuts consistently and be accurate, it can help you. Okay. So up first, A to B, right? I subtract the x's, square it, subtract the y's, square it. So what's negative 2 minus 1? Negative 2 minus 1. If you owe somebody $2 and you borrow another $1, you owe them. Thank you. So what's negative 3 squared? 9. So that's all I'm doing here, right? I'm taking x1 minus x2 quantity squared, and then I'm going to take y1 minus y2, square it. Okay? So what's 5 minus a negative 1? Double negative becomes positive. What's 5 plus 1? Squared. Okay. What's 9 plus 36? 45. Okay? Again, I don't need to reduce this. I can keep it as square root of 45. So I have this one side length, right? Yep, DAB. Yep. Here, let me write it up. DAB. We don't care too much about reducing these because all we're doing is we're trying to figure out which of these side lengths are equal. I don't really care what format they're in. I just want to know, are these sides equal lengths? Because I don't have anything to compare against it. Technically, you should reduce these, but I'm not going to flip out about it, okay? Because that one should be 3 square roots of 5. But if you have square root of 45, I'm cool with it. And like even on the ACT, real quick, on the ACT, if they ask you to reduce the radical, you don't have to. If you got a distance of square root of 45, do you really think that's going to be on there? No, it's going to be 3 square roots of 5, right? If you're like, oh, I don't remember, use your calculator. Type this in, you get a decimal, right? Which of the other ones match it in decimal form? Oh, this one, so that's the one you use. Like for me, I had to retrain my brain. I had to remember the ACT is not a math test. I'm just picking which of the 4 answers is closest to reality for this problem. So it's not a math problem, it's a pick the right answer problem. So I had to actually change the way I thought about it because I did the same thing. 5 minus a negative 1. Because I take my y's and I'm subtracting them, right? So I take 5 minus negative 1. What happens to the double negative? Becomes a 5 plus 1 is, and then I square it because that's what the distance formula says to do. So is everybody okay with how I'm working through these? So I'm taking the x pieces, subtracting them, squaring them, writing the number. I'm taking the y pieces, subtracting them, squaring them, writing the number. No. Okay, so everybody good, yeah? So here's DBC. Okay, same thing, B and C. What's 1 minus 4? Negative 3 squared is 9. What's negative 1 minus 6? Close. Negative 1, take away 6 more is negative 7. Squared is 49. What's 9 plus 49? 58. All right, so if you're okay with your mental math stuff on this, right, you don't need the calculator. You can cook through them pretty quick. If you're not 100%, use your calculator to help you out, okay? But if you notice, you don't have to write out the formula every time unless it's what you need to be more successful, okay? Everybody good with that, yeah? All right, so same thing here. This is DCA. So what's 4 minus a negative 2? 4 minus a negative 2. Positive 6 squared is 36. 6 minus 5 is squared. Add them. Okay, how many sides match? So what kind of triangle? Scalene. Okay, so we're just going to be using the distance formula to compare the 3 side lengths. Alright, if all of them match, it's equilateral. If 2 of them match, it's isosceles. If none of them match, scalene. Everybody alright with that? So it's a little bit of work, but are we okay with the process here? Okay. Because it gets very repetitive because, again, it's just applying the distance formula. Alright, up next is 31. What does number 31 say, please? 32? Everybody okay with that? So what are the 2 points for 32? Negative 5, 6, and 1 and 8. Okay, for this one, the directions want you to find the equation to the perpendicular bisector of these 2 points. So this is actually a 3-step process. You have to find big M, you have to find little m, and then you're going to use point slope form in order to actually find the equation. So if you don't know these formulas as I write them up, make sure you take notes on them and put them in your notebook so that way you have them to add to your cheat sheet for the quizzes. Okay? So up first is little m. What's little m stand for? Slope. And what's slope formula? Everybody okay with that? So I get 8 minus 6 over 1 minus a negative 5. Double negative goes positive. 8 minus 6 is 2. All over 1 plus 5, which is 6. This reduces to 1 over 3. Everybody good so far? Yes? No? Maybe? Any questions on little m? Everybody remember doing all this from last year? Okay, so once I have little m, the next thing I need to find is big M. And what does big M stand for? Midpoint. So I'm going to add the x's divided by 2, add the y's divided by 2. So what's negative 5 plus 1? Negative 4 divided by 2? Negative 2. What's 6 plus 8? 14 divided by 2? Okay. Now, before I get going too much further, what kind of a bisector am I looking for? Perpendicular. What do we know about perpendicular lines? Their slopes are what? That's half of it. Right, and opposite sign, right? So, for me, this is what I found for the slope of the line they gave me. I want to know what's the slope of the line that I'm going to make, right? Negative 3. Is everybody okay with where that came from? Yes or no? So to find your slope, you have to take the m that you calculated up here and use its opposite reciprocal. So you change its sign from positive to negative, and you flip the fraction. Okay? So now I have a point and a slope, so I'm going to use point slope form, which for those of you who don't remember last year's chapter 2, is y minus y1 equal m times x minus x1. Very good, very good. All right, so now plug in what you know. What's my y1? 7. What's my m? What's my x1? Negative 2. What happens to the double negative? Becomes a... Okay, so from here, I distribute on the right. So I get negative 3x minus 6. Okay, and then how do I get y by itself? Add the 7. So I get y equals negative 3x plus 1. And this is the equation of the perpendicular bisector formed between the 2 points, negative 5, 6, and 1, 8. So, a lot of steps, right? There's a lot going on, but it's all stuff we've used in the past. I'm just asking you to put it all together into a new process. And that's what you're going to really run into when it comes to advanced algebra. It's taking stuff you've already done and applying it to new settings. So we're taking the basic skill and applying it to a bigger subset, okay? It's like anything, right? Like when you play a sport, you don't magically just learn the sport, right? You learn sub-skills, and then you apply them to the game. We're kind of doing the same thing here, okay? We've learned how to do this skill, we've learned how to do this skill, and we've learned how to do this. Now I'm asking you to put all 3 processes together to answer a bigger question. So are there any questions on m, little m, big M, or slope-intercept, or sorry, slope-point form? Point-slope form. Okay, so little m is just the slope of the line they gave me, right? So what's going on here is, let me draw it because it'll make more sense. So we have some random line here, right? It'd help if I picked a color you could actually see. How about black? There we go. So we have some line, right? This is our left endpoint, and this is our right endpoint. And I want to find a line that's going to be the perpendicular bisector of this. So I need to find the point that's in the middle, and that, by definition, is our big M. So that's where that's coming from. Now, to find the line that's going to be perfectly perpendicular here and make a 90, I need to know the little m here, because I know that my slope of the blue line has to be this slope's opposite reciprocal. So I find the slope of the line they gave me, so that way I can calculate the slope of the line I'm trying to find. Okay. Does that make sense? Okay. So over here, I'm finding the little m, which is the slope of the line they gave me, so I can find the slope of my line. And then I need the midpoint, so that way I'm actually bisecting. So once I have my point and my slope, we can use the point-slope formula to calculate the equation of the line. All right, so it's kind of like background information, background, and then apply it all to actually get the answer. So you have to do work before you can do work. All right, everybody good with 32, yeah? Okay, so again, it's kind of lengthy, but hopefully it's not overly hard. It's just time-consuming, which is what this section is basically going to feel like. All right, 42. What does number 42 give you, please? 2 and y. Okay, and then is this a d or an m? Okay, and what's the distance? Square root of 41. All right, so this is the same thing as what we just started with today, right? What piece did they give me? The midpoint or the distance? Distance. So I'm going to start off by using my distance formula. So let me write it all the way out so you all can see what I'm doing up here. And again, how many variables can I solve for at any time? 1. So after I substitute in here, I should only have 1 variable. Is everybody okay with that? Yes, no, maybe? All right. So what's my d? What did they tell me my d is? Square root of 41. What's my x2 value? 2. Minus what's my x1? Negative 3 squared. Plus what's my y2? Just y. And what's my y1? Negative 1 squared. Everybody good? Yeah? Okay, again, what happens to the double negative becomes positives. All right, so I get square root of 41 equals, what's 2 plus 3? Squared. Everybody okay with that line, yes or no? Okay, again, what piece am I trying to isolate? The y, so I have to get rid of this square root, right? How do I get rid of a square root? How do I get rid of a square root? You square, so if I square the left side, I have to square the right side. So I'm going to square on the right, square on the left. What happens when you square a square root? What do they do with each other? They cancel out. So what do I have remaining on the left? 41, and on the right, I get the 25 plus y plus 1 squared. Okay, so now I'm going to try to isolate the power. So how do I get rid of the 25? Subtract it. So what's 41 minus 25? 16? Yeah. 16 equals y plus 1 squared. Everybody okay with that? Yes? No, maybe. Okay, so now how do I get rid of how do I get y by itself? What's the next thing I have to remove? The square. So how do I get rid of a square? Square root. These cancel. What's the square root of 16? Close. Not 4, but plus or minus 4. So you should always be getting 2 answers out of these. Okay? What do I have remaining on the right? Y plus 1, right? How do I get y by itself? Subtract 1. So you get y equals negative 1 plus or minus 4. So what's -1 plus 4? 3. And what's -1 take away 4? -5. Whenever you square root a number, you always get the plus or minus, because what's 4 squared? 16, right? Right, 4 squared is 16. What's -4 quantity squared? It's also 16. So when you square root, you get 2 answers because you have 2 possibilities. Okay? So those are your 2 answers. Y equals 3, Y equals -5.